students, today we will discuss about graphical study in kinematics. Every year there is guarantee question from kinematics, that too from graphs, either in medical entrance or in engineering entrance. And the graphical study of motion involves the relation between three quantities. First one is a displacement. And we know that displacement is the change in position. And from displacement to velocity. You may be given displacement graph and asked to find out velocity. Or you may be given velocity time graph or asked to find out displacement. And we know that the rate of change of displacement is velocity. So we can say in another way, the first derivative of the displacement is velocity. What is first derivative? Nothing but tan theta. And what is meant by tan theta? In coordinate geometry from your mathematics, that is slope. So the slope of displacement time graph will give you velocity. Similarly, from velocity to acceleration. And we know that the rate of change of velocity is acceleration. And so acceleration can be obtained from slope of the velocity time graph. Now in reverse, we know from definite integration or applications of the integration. The reverse process of the differentiation is integration. And integration is nothing but from coordinate geometry, area under the curve. From displacement to velocity slope of a graph given, and velocity to displacement area under the curve. Similarly, slope of the velocity will give you acceleration, and area under the curve acceleration will give you the velocity. This is the very easy and simple technique. Whenever in physics you find differentiation and integration, the same quantities involved with graphs can be obtained easily by slope and area. And for understanding of the students, we have developed one simple flow, what we call this as the workflow or brain map or concept map or flow chart also. See here, displacement versus time. And from this, what is the velocity? Velocity, we know that the slope of the displacement versus time can be given as velocity versus time graph. And similarly, from velocity versus time graph, what is acceleration? Acceleration is obtained from slope of the velocity. And in reverse, again, from acceleration versus time, what is velocity? And velocity can be obtained from acceleration in reverse direction with the area under the curve. And similarly, from velocity time graph, if I want displacement, then area under the curve. This is a very simple procedure and you can solve problems very easily. And before going into the problem solving, let us understand about the nature of the graph with respect to slope. That is very important conceptual understanding. So our discussion is now slope versus nature of graphs. Suppose if any quantity is having zero slope, what is meant by zero? Slope is nothing but tan theta. So here tan theta is 0. When tan theta is 0, theta is 0. So the slope of the graph or straight line is 0 means what? It is parallel to the x-axis. So if I take the coordinate geometry like y-axis and x-axis, and here zero slope means the graph should be parallel to the x-axis as shown on the graph here. This is very simple. Parallel to x-axis means parallel to horizontal axis means zero slope. Whenever you get zero slope for any quantity, then graph will be always parallel to x-axis. And the next one, positive slope. Suppose if any quantity is having the slope as positive slope. What is meant by slope? Tan theta. Tan theta is positive. So from the basic trigonometric function which you have studied in your 10th standard is all silver teacups from the first quadrant, second quadrant, third quadrant and fourth quadrant. In first quadrant all functions are positive, second quadrant only sign positive, third quadrant only tan positive and fourth quadrant only cos positive. Here slope means tan theta. So tan theta is positive means third quadrant and first quadrant. So let me take the coordinate axis as shown in figure here, x-axis and y-axis. And positive slope, let me take any arbitrary line which is making an angle, let us take it as a 60 degrees just for example purpose. And here this line represents positive slope. Why? Because in first quadrant tan theta is positive, and if you extend to third quadrant also, here that will also positive. Here it is inclined to positive x-axis. Another way to identify it is. Now, easily you can represent in another way. The notation is theta is greater than 0 and less than 90. That is first quadrant. Now, regarding the negative slope. Negative slope means where tan theta negative. Tan theta negative means it should be like this. And the theta with the positive x-axis must be greater than 90. And it looks like this, it looks like it is inclined to negative x-axis, the nature of the graph. See, let me take coordinate axis here as shown in figure, y-axis and x-axis. Let me take a line or graph which indicates the negative slope here. Here if you observe this line, here the theta is greater than 90 and it looks like it is inclined to negative axis. It is inclined to negative axis, even though it is appeared in first quadrant, but still the nature is inclination is towards negative axis, the slope is negative and theta is greater than 90. Let me take example as 120 degrees here. This is about negative slope. Next, increasing slope. Suppose if any quantity is increasing in nature, the slope is increasing in nature, then how would it be increasing? Slope you know very well. Slope is nothing but, slope is the tangent for any curve. Slope is nothing but a tangent, because slope is tangent function. Now let me take again y-axis and x-axis here. Suppose if I take an arbitrary curve like this, let me take initial slope. Initially let me take an arbitrary point here, let me take the tangent for that one and assume it as the theta 1. The slope is little bit very small. It is inclined to x-axis and value is small. Suppose if I take later some other point here, then if you take here the tangent at that point, again horizontal axis imaginary, and if you measure the theta here, it is theta 2. And if you observe carefully here, theta 1 is small and theta 2 is large. And theta 2 is greater than theta 1. That means initially slope is small and gradually it is increasing. That means the slope is increasing for this curve. Simple. Increasing means the curve will be like this. Increasing like this. Increasing nature. Okay. And here the relation is theta 2 greater than theta 1. That means later tangent must be greater than first earlier tangents. Okay. Similarly for decreasing slope, reverse. Initially slope will be more, later slope will be less. So for increasing slope like this, for decreasing slope like this, reverse. Let me take y-axis and x-axis, and if I take the arbitrary graph, you can observe initially the tangent represents the more slope and later less slope. Here theta 2 and theta 1. Here also same, theta 2 initial angle is larger and later angle is smaller. See here the slope is decreasing. Decreasing means like this. Increasing means like this. Okay, this is the nature of the graphs. Now let me take the understanding and application of the student is tested more than the concept. A body is thrown vertically upward. A body is thrown vertically upwards. Which one of the following graphs correctly represent the velocity versus time? And here the question is about velocity graph. And velocity graph can be obtained from displacement and it can be obtained from acceleration. From displacement you should take slope. From acceleration you should take area under the graph. Now, just conceptually, we know that for any body which is projected upward, the body will move upward and again come back. But the important thing here, the the force, gravitational force, which is pulling body backward, is responsible for acceleration downward. Here, the acceleration on body always downward. Initial movement of the body upward. So acceleration direction is opposite to the initial direction. So acceleration is negative. Whenever acceleration is negative, slope of the velocity must be negative. So if you observe in these graphs, for which option you have negative slope for velocity, that will be your answer. If you observe option A, the slope of the velocity is changing, but acceleration is constant for this one. So first option wrong. Second option also slope is initially positive, later negative. And here initially negative, later positive. And fourth one, only option which is having constant slope, that too negative, that is option D. Displacement versus time to velocity is slope and velocity time to acceleration it is slope. Here we know that acceleration of the vertically projected body is always negative, minus 9.8 meter per second square. So velocity should be having negative slope, constant slope, that too negative. This is the key idea. Let me take another question, which is very important, and this is a level 2 question which was asked in 8th April 2019 shift 2, that is afternoon paper. A particle starts from origin O from rest. What is meant by from rest? Initial velocity is 0. Just if you understand that word, the rest itself indicates the initial velocity of the body is 0, which will give you one of the option possible here. Option B represents initial velocity 0. And don't come to conclusion immediately. Just a possibility. B might be correct answer. And now with a uniform acceleration means acceleration is constant. Acceleration constant along the positive x-axis. Acceleration is not 0, be careful. Acceleration is constant. So whenever acceleration is constant, the slope of the acceleration must be 0. So acceleration graph might be straight line, horizontal, parallel to the x-axis. So option A also possible here. Now, identify all the figures that correctly represents the motion qualitatively. Here the graphs are given for acceleration, velocity and displacement. So let us go one by one the procedure. What is that procedure? Read the question carefully. From the question, a particle starts from origin O from rest. Rest means what? U equal to 0. And which is given also that uniform acceleration. Uniform acceleration means A is equal to constant. A equal to constant means what is A? Acceleration. What is acceleration actually? Slope of the velocity. So the slope of the velocity must be constant. Slope of the velocity constant means it must be increasing uniformly. The rate of change of velocity must be constant. That what we call increases uniformly. Now, we know that from displacement, velocity can be taken as with the slope, and from velocity, slope as acceleration. And let me think about the acceleration. A is constant. As A is constant, the slope of the A must be 0. As the slope of the A 0, it must be parallel to the horizontal axis. That is straight line parallel to x-axis. So for acceleration, conclusion completed. And for velocity is also constant slope but increasing uniformly. So it is a straight line with a positive velocity, positive slope, constant slope, that too positive. Now for displacement, as velocity is positive slope, constant, and displacement should increase, displacement should increase in slope. Why? Because velocity is positive. So displacement graph, the slope of the displacement graph must be, slope must be increasing in nature. That means slope must be like this. Well, for displacement. For velocity, constant slope, that to positive. And for acceleration, parallel to the x-axis. These three conclusions completed. So let us try to interpret the answer with this discussion. Now, and we know that for acceleration, constant slope, that to parallel to the x-axis. So option A is correct. Now, next one. For velocity, we know that for velocity here, the slope must be constant, that to positive slope, and according to the given information, it should be, and initial velocity should be rest, so it must start from the origin, right? So definitely option B is suitable for that condition. And coming to the displacement, now the displacement is, it must represent the constant positive velocity. So the slope of the displacement curve must increasing in nature. So increasing slope graph should be taken. So that is definitely among C and D, D is suitable. So option A, B and D are correct answers for this one. Now if you observe the question carefully, here the examiner intention, the National Testing Agency, examiner intention is to test the students' basic conceptual knowledge and also application. Very simple. Now, let me come to the next part, that is reverse process, area under the curve. That means from acceleration to velocity, from velocity to displacement. See here, we know that from basic discussion, earlier we have discussed that displacement versus time to velocity is a slope and velocity to acceleration is a slope. And backward way, acceleration to velocity is area under the curve, and velocity to displacement, that is also area under the curve. And here a typical graph, let us take. In this one you have different kind of the partition, the total area under the curve. So here let me take the first one as A1 and then A2 and then A3. Here the graphs above the x-axis should be taken positive and the graphs below the x-axis should be taken negative. So plus A1 minus A2 and plus A3. That is the total area under the curve. And let me take directly a typical question which was asked in 2004 IIT. Earlier it was descriptive and objective both, and this is the part of the objective paper. At t is equal to 0, particle is at rest. Then the maximum speed achieved by the particle. Speed, it is not velocity. For velocity, you should take sign plus area minus area. Above the x-axis positive and below the x-axis negative. But for speed only magnitude of the velocity. So here you should understand clearly, for speed we don't take plus a or minus a. That is why we can consider that for speed and distance always, area should be added, not subtracted, even it is below the x-axis. And here it is very simple, from acceleration, speed. So area under the curve. Area under the curve, what is the shape of the area here? Triangular shape. So half into base into height, half into base is 11 units and height is 10 units. So half into 11 into 10, that is 55 meters per second. Option C. Very simple question. Now, the recent question 2020, mains 2020 September, that to shift to. The speed versus time graph is given and the distance is asked from 0 to 5 only. So consider 0 to 5. Again it represents, the shape is triangular. So half into base into height. Here, what is the base here? 5. What is the height here? 8. So half into 5 into 8, that will give 20 meters only. The units are here 20 meters.